write x squared minus 6x plus 9 in factored form. How do I write a polynomial in factored form? My teaching assistant Chloe is here with her latest cheat sheet notes. She wants you to know that when you are factoring, ask yourself, can you pull out a greatest common factor? And then there are 4 factoring patterns that we're going to talk about: difference of squares, perfect square trinomial, difference of cubes, and the sum of cubes. And when you are raising a power to a power, you multiply the exponents together. Now that we have Chloe's cheat sheet notes, we can go ahead and write this polynomial in factored form. So the first thing I wanted to show you is just one technique on how we can go ahead and factor this. We have x squared minus 6x plus 9. We can go ahead and look at the leading coefficient. The leading coefficient is the number in front of the highest degree term. X squared is our highest degree term, so the number in front of that is 1. That is our leading coefficient. So we take our leading coefficient and multiply it by our constant, which is 9. So if we take 1 times 9, we get 9. How else can we write two numbers being multiplied by each other that will give us 9? We could have done a positive 1, positive 9, negative 1 and negative 9, positive 3 and positive 3, or negative 3 and negative 3. Now the second part of this is to look at your number that is in the middle in the b position. Remember, this is in standard form, ax squared plus bx plus c. So in our b position, we have negative 6. So whatever numbers we multiplied by each other to give us 9 have to add together to give us negative 6. So on our first one, we have 1 plus 9 equals 10. The second one, negative 1 plus negative 9 equals negative 10. 3 plus 3 equals 6. And our last one, negative 3 plus negative 3 equals negative 6. So we had to multiply to give 9, add to give negative 6. So the one that works for that is our last one right here. So we have negative 3 and negative 3. So I can go ahead and write this as x minus 3 times the quantity x minus 3. So it's x minus this 3, x minus this 3. If the answer was negative 1 and negative 9, it would have been x minus 1 and x minus 9. So from here, you can see I have x minus 3 twice. So I can actually write that in a little bit more simplified version by writing the quantity squared. So this is the final answer. This is one technique on how to factor. But what you end up starting to notice once you start to get really good at factoring is sometimes there are factoring patterns. And this example right here does have a factoring pattern. This one falls under the perfect square trinomial. So when we are looking at this one, we can go ahead and see that we have it written in a squared minus 2ab plus b squared. That is already written in that form. And if it helps you to write it underneath it, go ahead and write that. So we have a squared minus 2ab plus b squared. So what I'm going to do is write my a squared. I know that a squared is equal to that x squared right there. But if you notice here in my answers, I need to find an a and a b so that I can subtract them and square them. I don't really need the a squared or the b squared, but that's what this formula gives me. So if I need an a, how do I get rid of the a squared? What I'm going to do is take the square root of it. And when you take the square root of one side, you have to take the square root of the other. And when you are taking the square root of a square, they actually will cancel each other out. Because remember, there is really an index or a root of 2 out here. And 2 over 2 equals 1, which would equal a. Or x would be 2 over 2, which is equal to 1, which is x. So from here, we really get a equals x. Now I have my a, now I just need my b. Now we know b squared is equal to 9. So how do I get just a b by itself? I'm going to go ahead and take the square root of both sides. When I am taking the square root on the left, the square root symbol and the 2 will cancel out. And 9 is actually a perfect square. So b will equal 9. And then the other thing that I have to do on this perfect square right here, that's it. I just needed to, I can double check to make sure my negative 2ab works. So I'll do that one next. So if I have negative 2ab, that would be negative 2 times a, which we determined as x, times b, which is equal to 3, and that ends up equaling negative 6x. And we did this Just to verify, notice that negative 2ab is negative 6x. So it does look like I do have a perfect square trinomial. So from here, I'm going to go ahead and just rewrite this equation right here. So I have a squared minus 2ab plus b squared does equal the quantity of a minus b squared. So when I am writing mine in, my problem was x squared minus 6x plus 9. Now I just have to take my a minus my b squared. A was x minus my b, which is 3, quantity squared. So you can see there were two different techniques I used to solve this problem.